high school with Teller. Yeah, Teller, from Penn and Teller. We were chatting and he told me that he went to high school with Teller, from Penn and Teller. What are the odds? Probably less than you think. Ladies and gentlemen, Stuart Firestein.
Oh, there's a button. Who'd have thought? A button. Thanks very much. It's going to be hard to top that introduction now, isn't it? I'm afraid. This is a wonderful venue to be at. It's my first time here. I can't tell you how pleased I am to be able to speak to an audience like this. And I can't believe the number of people. It's nice to see you all coming out for ignorance, uncertainty, and doubt. I can always use your support. So there's an ancient proverb which says that it's very difficult to find a black cat in a dark room, especially when there's no cat. And that seems to me to be a perfectly apt description of science and the scientific way we do things, the way scientists do things, which I think is somewhat different than what many people may feel is the case. I think there's a notion that science is a very ordered progression of events. It's a very rule-based sort of system, something we call, I guess, the scientific method that governs how we do things in this very orderly and concise way, and we gain facts and we write them down and so forth and so on. But the fact of the matter is, it's mostly kind of farting around in black rooms looking for black cats that may or may not actually be there. And it's this difference, I thought, that occurred to me at some point in the perception of how we do science versus the way we actually pursue it that got me interested in this notion of ignorance, and I wound up writing a book about it. But the book itself is actually based on a course that I teach at Columbia University called Ignorance. And Columbia is, as you can imagine, quite proud of me for putting this course in our bulletin. So, but that course grew out of, I think, the notion, this difference that I sensed in the way science is perceived and pursued, that comes out to some extent from my dual role at Columbia as both the head of a laboratory that works in the field of neuroscience, specifically in the sense of smell or olfaction, and also as a professor who teaches a course there. So, working in a laboratory with graduate students and postdocs, thinking up and doing experiments is really, it's just the time of your life. There's nothing better I can think of doing. It's fascinating, it's endlessly interesting, it's engaging, and it's kind of, well, I guess, exhilarating somehow. So in addition to that, though, as my role as professor, I also had to teach a course with the daunting name Cellular and Molecular Neuroscience 1. This course, as you can imagine, was a rather large course. It was 25 lectures that I had to prepare, and that was kind of a challenge. It was interesting as well. There's a lot of material to put into it and so forth. But I have to admit, it wasn't really exhilarating. And so the question was, what was the difference? Well, this course, this textbook that you see pictured here, it comes in at a little over 1,400 pages. It remarkably weighs a whopping 7.5 pounds. The students refer to it as the hernia book. I'll mention, just as a matter of perspective, that 7.5 pounds is about a little more than twice the weight of an adult human brain. It's not clear why this book is about the brain. So just to put it in another kind of perspective, here's, let's see, do I have that? No, I don't have the pointer. So the big book there, the big white book, the two books on end, the big white book is this Principles of Neuroscience, and the other book is Darwin's Origin of Species. And you can see we've come a long way. So what I began to realize was that in teaching this course and using this book, I had given students a kind of a notion, perhaps, that we pretty much knew everything there was to know in neuroscience, and that's certainly not the case. And further, I think they had the idea that science is basically about accumulating facts and putting them in big books like Principles of Neuroscience. And that's also not what it's about. And indeed, that last slide, which you could bring up again if you will, was a quote from Marie Curie, who in a letter to her brother, upon receiving, mind you, her second graduate degree, wrote him that one never notices what has been done, one can only see what remains to be done. And I thought, well, this is really what we have to teach students. This is what we have to talk about, the what remains to be done, because that's what the science is really about. I have to say, this is one of my favorite pictures of Marie Curie. Sorry, which she just took off. Can you put that up again? Sorry. because I'm convinced that that glow behind her is not actually a photographic effect. Actually her exposing the plate, I think. So remarkably, this is true. Her papers are maintained in the Bibliothèque Française in Paris, and they are in a concrete room in a lead-lined box, and you have to put on a radiation suit if you want to go work with them if you're a scholar. They're still so hot, remarkably. So, so I thought this was the idea that we should really begin teaching the what's not known, if you will, the ignorance. And so I started this course on ignorance, actually, which I'll talk about perhaps in a few moments, and that eventually became this little book. Now, I should say that I use the word ignorance, at least in part, to be intentionally provocative, and I don't mean some of the bad things that the word connotates. It has many bad connotations, especially in common usage, and I don't mean those. So let's get those out of the way. So I don't mean, for example, the kind of ignorance that's just sort of stupidity or willful stupidity, even worse, a kind of a callow indifference to fact or data, an indifference to the reality of what's going on around you. The ignorant are uninformed, unenlightened, unaware. I know that's sort of a cheap shot, I know. But to be honest with you, I really did look around for a graphic for a while, and then I finally thought, well, there's really not much you can do better than that. So I don't mean any of those kinds of ignorance. What I do mean, though, is a kind of ignorance that was talked about by James Clerk Maxwell, probably the greatest physicist between Newton and Einstein, who said that thoroughly conscious ignorance is the prelude to every real advance in science. And so it was this idea of thoroughly conscious ignorance that I thought was really the important thing to think about, and that's kind of what this class is sort of about, which I called ignorance, and it consists primarily of having members of the science faculty, both from Columbia and elsewhere, come in and talk for a couple of hours in an evening with a group of students about what they don't know, what they'd like to know, why they want to know this rather than that, for example, why it's more important to know this than that at the moment, what will happen if they know this, what will happen if they don't know this, what didn't they know 10 years ago that they know now, what didn't they know 10 years ago that they still don't know, and all of those sorts of questions. I call them sort of case histories in scientific ignorance, and we also, sorry, I messed that up, well, doesn't matter. We also attempt to have a variety of discussions about not only the limits of science or knowledge or things like that, but the limits of ignorance, if they are, and models of science. So there's several common models of science. That's one of them. One of them is the idea of scientists patiently piecing a puzzle together. I think that's kind of wrong, because the fact is that with puzzles, the manufacturers guaranteed a solution, and we have no idea about that, really, in this world. Another one is this notion of an onion, if we can have the slide back up again, that somehow the science is a question of peeling away layers of an onion to get to some fundamental truth. Another popular and rather attractive one is that of the iceberg, where we only see the tip of the iceberg. There's the great unknown that's not available to us, and so forth. And these are all very nice, but I think they're fundamentally, in a way, not quite the right image for science, because they're all a bit static. They're all a bit, if you just chip away, you'll get there. I prefer something maybe a little more poetic, if you will, but I prefer this kind of an image, which is sort of the ripples on a pond. So if you think of our knowledge as what's inside that ripple, and that grows and grows, but as it grows, so does the circumference increase, the circumference that's in touch with the ignorance all around it. And so that as knowledge grows, so grows ignorance as well. And I think that's a critical idea in science, that we generate and produce ignorance. This was sort of captured quite well in an interesting toast by George Bernard Shaw. He was actually at a dinner feting Albert Einstein. So this was his toast, in which he says, science is always wrong. It never solves a problem without creating 10 more, which I find kind of a glorious sort of an idea, actually. And I'd like to say, just to name drop a little bit more, that apparently he actually cribbed that from Immanuel Kant, who about 100 years earlier came up with this idea of the principle of question propagation, suggesting that every answer begets a fresh question. Of course, in his inimitable way, Shaw increased that by an order of magnitude, but that's okay. I think he's probably right. And so this is the notion then, really, that yeah, this is my other favorite guy, but that science continues to create and develop the unknown, and that, of course, there are known unknowns, as we've heard a couple times today, and there are unknown unknowns, as stated so well by Donald Rumsfeld when he was kind of confused at the beginning of the war in Afghanistan after 9/11 and the bungled response there, but his worry was, correctly, not only are there things we don't know, but there are things we don't know. And indeed, I think that's an issue that's of some importance and needs to be considered. This was said somewhat more eloquently, perhaps, by J.B.S. Haldane, a famous mathematical biologist, who said, not only is the universe queerer than we imagine, it is queerer than we can imagine. Although I don't think it's queerer than that suit that he's wearing. That's another story. So we do have to confront this. Nicholas Rescher, a wonderful philosopher of science at the University of Pittsburgh, coined the term cognitive Copernicanism, which he means to say that in the same way that Copernican ideas showed us that we're in no particularly special place physically, it may be that our mental landscape has nothing special about it cognitively either, and that there may be things that we cannot quite grasp, or there certainly are things that we currently can't grasp, but will perhaps eventually be able to do so, and that this is the notion of being able to actually study ignorance, if you will, that we could talk about kind of the way epistemology studies knowledge, we could study ignorance in the same way. And a lot of that is in the book, and I'm going to leave that for there, because another issue has come up that I would actually like to use this forum to discuss, and that issue came up in a review of the book, a very decent review, a very kind review by none other than Michael Shermer, who might even be in the audience, I'm not sure, but was here earlier for sure. Michael was very kind in the review, said very nice things, but also brought out a very important point that I hadn't really considered carefully, and that was that hitting on this ignorance idea and saying that science generates ignorance, that it's an important part of it, sort of opens the door to a kind of an abuse of that idea. It opens the door to charlatans and quacks and cranks and all the rest of that to suggest that science maybe is uncertain or doubtful somehow or another. And so I'd like to kind of look at that idea today with you and see if we can work our way through that in a way. So assuming that you agree with me that scientific progress, among other things, generates greater and greater ignorance, hopefully better and better ignorance, then we can ask ourselves whether ignorance in some way equals uncertainty, whether uncertainty therefore in some way equals doubt, and does that mean that science basically generates or creates uncertainty and doubt? And the answer, I think, is a resounding, leave that up, a resounding no, I don't know. Well, it's a resounding yes. I think this is the second version of this presentation that we should be using, but that's all right, this is close enough. So it degenerates a resounding yes, but the important thing is that uncertainty is not the same thing as unreliability. And I think that's a key point that has to be made and kept in mind. And I'm going to talk about that for just a moment. So, all right, science being the search for better ignorance, I'll use one more quote from Erwin Schrödinger, a great physicist and I believe philosopher, who claimed that in an honest search for knowledge, you quite often have to abide by ignorance for an indefinite period. I think that's quite true, but let's see what that actually means if we can. So taking a kind of a perspective on this using the weather, not so much climate change, but just the weather, we could track, as a colleague of mine named David Halfand, an astronomer does, Columbia, track the evolution from primitive ideas to more scientific ideas. So among primitive humans, the idea of a hurricane, for example, might be that the wind is angry. Maybe only slightly more evolved than that would be that the wind god is angry, and maybe you can somehow mollify the wind god or something. But the scientific idea, of course, that we've come to now, one hopes, is that the wind is a measurable form of energy. Now, quite arguably, the first two of those phrases, they're now gone. Okay, the first two of those phrases are a complete and total explanation. They're useless. They're non-informative, they don't tell you what to do or give you any place to go, but they are a complete and total explanation. The third one, on the other hand, is not at all a complete explanation, it's just the beginnings of one. It means we can make some measurements, we still don't really know how to predict the weather in any clear way, or even how to understand turbulence and wind and so forth and so on. But it's clearly the more useful, the more potent and engaging answer. Similarly, we could go to the case of the black swan, which has been mentioned a couple times and was made somewhat popular by his name is in And Nassim Taleb in his book, The Black Swan. You should leave this slide up. I'm going to go through a couple of things of it. So in the case of the black swan, let's take this as an example. The theory is that all swans are white because that's what everybody had always observed. And, but it is also true, I don't know how well you can see this, I don't know if that print's too small, but it is true that one black swan overthrows the theory. But it does not invalidate the data. And I think that's what's important to also realize. The data that's true under a particular regime remains true under that regime. The regime may change, but the data remains true. And in fact, in this particular case, by virtue of a new observation, that of a black swan, the data that we had about white swans actually improved, not denigrated, because now with the appearance of a black swan, we can ask a whole raft of brand new questions that we didn't even know to ask before. How is it that there's such a preponderance of white swans rather than black ones? Is an advantage to being a white swan rather than a black one, et cetera, et cetera. How's pigmentation of feathers controlled? How many colors could swans actually come in? So the point is that new questions are now available that we couldn't have even have asked before we knew there were black swans. And so the theory doesn't go up in flames, if you will. Close. The theory doesn't go up in flames. What happens is there's revision. And this is the second critical point about science. In science, revision is a victory. And that's a critical idea. This is what we do. Revision, science is a work in progress always. We welcome revision, we consider it a triumph and a victory. This is not the case in most other belief systems, in particular, I would say religious-based ones, where revision is usually a kind of an embarrassing bit of a wiggle of some sort or another. And so this notion of revision, I think, is critical. So we can go back now to Schrodinger's prescription here that we have to abide by ignorance for an indefinite period in any search for knowledge. So this sounds like a fairly simple and straightforward prescription, but actually it's somewhat more difficult to put into practice. And I think the problem here is that the human mind has not evolved to deal with doubt and uncertainty, let alone ignorance. And we can see this actually quite simply in a couple of examples using visual illusions, things known as ambiguous figures. So you're probably familiar with most of these. Here's one that looks like a very attractive woman looking away from us. This is from a cartoon in the New Yorker in which she claims that she's turning into her mother. And the reason is that you can also see this as an old hag. Right, so you can sometimes see it as a profile of an old hag, or you can see it as a very beautiful woman looking away. The point is, the critical observation here is you can never see it both ways at the same time. You see one or you see the other, and you flip instantaneously back and forth in your mind. There's no middle ground or middle place. Another example that's sort of famous is the Necker cube, which for many of you should probably look as if it's coming out of the screen and down and to your right. If you just, one way of doing this is sort of change the lighting a little bit. Sometimes that works, sometimes not. But it will flip so that it now looks like it's coming out of the screen and up and to your left. And it doesn't really require lighting. You can do this. You can flip back and forth on this. But once again, you'll see that you're flipping back and forth. You never rest at some intermediate place. There's never doubt anywhere about this. Particularly telling example of this I discovered recently in, of all places, this little basement, funny, that's very appropriate for this meeting, this funny little basement museum called the Musée de Magique, the Magical Museum, in the Marais district of Paris, down a scary looking flight of steps. And this exhibit is there, and it's called The Two Brothers, Les Deux Frères, by a fellow named James Hodges. I haven't been able to track down who he is. So watch what happens here. This is a movie, and what's going to happen is that disc is going to rotate. And it's going to rotate, I hope, very slowly. And you will suddenly see the second brother appear. So what's remarkable about that, let me see if I can run that again for you. What's remarkable about that is no matter how slowly you do it, you see one brother, and then it begins to move, I hope. Let's see. Yes, there we go. But you'll see there's no intermediate moment. There's no transition. Bingo. It's there. And no matter how slowly you do this, you'll never see anything in the middle. And so this is kind of the problem, I think, that we face in dealing with the public and their attitude towards science, because they've been taught by the press, by an educational system that gets it wrong, I think, in many ways, all the way up through college, not just the early education, but all the way up through university and through courses that I, in fact, have taught myself, that the values of science are fact, surety, and conviction. And that's not the case. The values of science are, in fact, ignorance, doubt, and uncertainty, and our ability to live with those without thinking that that makes it unreliable is crucial, because this, in fact, ignorance, uncertainty, and doubt is precisely what should give us confidence in the scientific method as the best way to learn about the world. Not to have the last word, I'll give it to Václav Havel, the poet and playwright and first president of the Czech Republic, and in a quote that's probably well known maybe to many of you as well, but I think has particular interest in this regard. He says, "Keep the company of those who seek the truth, flee from those who claim to have found it." Thank you very much.
Stuart Firestein. Ladies and gentlemen, Stuart Firestein.
Oh, there's a button. Who'd have thought? A button. Thanks very much. It's going to be hard to top that introduction now, isn't it? I'm afraid. This is a wonderful venue to be at. It's my first time here. I catch that may or may not actually be there. And it's this difference, I thought, that occurred to me at some point in the perception of how we do science versus the way we actually pursue it that got me interested in this notion of ignorance, and I wound up writing a book about it, but the book itself is actually based on a course that I teach at Columbia University called Ignorance. Columbia is, as you can imagine, quite proud of me. I can't tell you how pleased I am to be able to speak to an audience like this, and I can't believe the number of people. It's nice to see you all coming out for ignorance, uncertainty, and doubt. I can always use your support. So there's an ancient proverb which says that it's very difficult to find a black cat in a dark room, especially when there's no cat. And that seems to me to be a perfectly apt description of science and the scientific way we do things, the way scientists do things, which I think is somewhat different than what many people may feel is the case. I think there's a notion that science is a very ordered progression of events. It's a very rule-based sort of system, something we call, I guess, the scientific method that governs how we do things in this very orderly and concise way, and we gain facts and we write them down and so forth and so on. But the fact of the matter is, it's mostly kind of farting around in black rooms looking for black.
Stuart went to high school with Teller. Yeah, Teller from Penn and Teller. We were chatting and he told me that he went to high school with Teller from Penn and Teller. What are the odds? Probably less than you think.